Hey everyone. So welcome to this first lesson or first session for Python for beginners, right? Um, and so the idea with this course it was that the idea of the platform is to be focused on deep learning and machine learning applications and teach you how to get it up and running with the latest in that field, right? And Python is a language that is very key to machine learning applications, right? And if you followed some of the sessions till now, and if you keep following different courses on deep learning and machine learning, a lot of the packages modules used to build deep learning and machine learning models are based out of Python. So the idea here is if you've never done coding before, or if you've coded but you're not familiar with Python, then Python for beginners will kind of get you up to speed with the basic idea of Python. And then we'll have another course or two on Python for data science and how you can start applying more advanced concepts in Python. Uh, that way, when you kind of do the deep learning, machine learning courses, that's something you're interested in, then it'll help you there. And if not, you're just trying to learn Python because it's useful in your career in some way or for your school or whatever, then hopefully this will help you out. So, because this is the first lecture in this series, let me introduce myself. My name is Anil. And I've had a chance to work with Python for the past 12 years or so, primarily working on building computational models, right, for engineering applications. A lot of it focused on aircraft and different types of design and modeling physics, and of course, in machine learning and deep learning. So hopefully, through this course, I can, share a little of what I know and help you get up and running with Python for whatever application you're trying to build. Okay, so let's get going. So this lecture is very introductory. Is just to get you up and understanding some of the basic ideas of coding, so that when we start talking Python, you understand what we mean. So first question is, what is coding? Right? You hear this term a lot. So the idea is you're basically trying to tell a computer or a machine what you want to do, and you want to give it a set of instructions. So that set of instructions is typically, written in an interesting, in a structured way, and that is a program. So coding is the art of writing a program to tell a computer what to do. So think about it this way, right? Now, you're, this person standing in front of an ice cream stall. You speak English, and the ice cream stall person speaks Hindi, right? You don't know how to communicate to that person. Okay, you could use sign language, but you want to find a way to talk. So how would you do that? So, well, what you do is try and find somebody there who understands both languages, right? Somebody who understands and speaks English and Hindi. That person would effectively then act as a translator or an interpreter for you, right? You tell that person what you wanted, which type of cone you wanted, or if you wanted a choco bar or so on. That person would talk to the ice cream stall person, and vice versa, and help you communicate. Right now, obviously, today you could use apps out there. You could use translation apps like Google Translate and so on. Modern smartphones come with translation tools built in as well. But effectively, you'd have a medium somewhere in between, and you'd talk to that medium who would talk to the other person. And hopefully, at the end of it, you get your ice cream. So now, what if you're actually trying to get a machine to do something, right? And you need to communicate with it. So what you do is you understand a certain language, you kind of provide instructions to the computer, telling it what to do and what not to do. And that language you provide instructions in is called a programming language. Now, does a computer understand a programming language directly? Well, the answer is no, right? Think about it this way. Any language that you speak, whether it's English or Hindi or French or German or Spanish or whatever, it's got a structure, it's got a grammar to it, there are words and sentences. The computer, only understands ones and zeros, right? The chip eventually is all about ones and zeros. So it only understands binary. And so what you are going to do is do something in between where you're going to have a programming language, which kind of is based off basic, has a basic structure and uses words that you understand, primarily English words, right? So you have a lot of languages. And then there is a way to take this programming language and convert it into the binary code, which then the computer executes. And so there are, you can look at programming languages primarily as two types. You can have high level and low level programming. So this is an example in Python, right? Given the course is on Python, let's start. You want to write a simple, piece of code to add two numbers. So you say I'm going to have a variable a, and a variable is a container that just stores the value, right? We'll get to variables in the next set of lectures. So you say a is 5, you say another variable b is 3, and then you say the sum is a plus b. So a plus b is computed, stored here, and you say print sum. As the name suggests, it's going to print it out on the screen. So as you can see, fairly easy to understand, fairly easy to write, right? So it's a high level language. If you were writing this in some form of low level language, and this is not necessarily a very specific low level language, it's a general assembly language kind of thing, it would be slightly more complicated, right? You would have to use kind of terms like this. You'd say something like move R1 5, where actually here R1 is A, and you're saying R1 is register 1. So you're telling it, I want 5 to be stored in a particular register in the computer's memory. Same with 3. Then you create a temporary register and you add these two and store it here. Then you move that to a variable called sum, and then you call what is called a print statement. So as you can see, this looks okay for a simple program, but if this was a slightly more complicated program, to do something more complicated, doing this step by step, writing this step by step would be very complicated. It will take you a lot of time and effort, and it would be hard to build a scalable system. And then what the computer would have to do is then convert this to something like this, right? Which, if you are going to do this by hand, I mean, it's not going to be easy. So looking at the basic differences, a high level language, right, kind of provides a level of abstraction, meaning you don't have to understand or worry about the nitty gritty of how it's implemented. It kind of is fairly similar to kind of something you would understand, whereas a low level language is basically a clear set of instructions to the computer's hardware, right? And so as we said, a high level language is closer to human language, whereas the low level is fairly close to what machine language would be, which means a high level language is easy to read, write, and maintain because you can understand what's happening, whereas a low level language, a lot harder to do. Also, a high level language typically is quite portable, right? There are general ways to write these codes. And so you can take that code and then run it in a different machine, whereas a low level language is generally written in a way that's very specific to the hardware. And so because this is more portable and more general, obviously there'd be more steps to kind of get it closer to machine language and finally execute it. Whereas here, well, it's designed for that particular machine. It runs very quickly. And so the example of high level languages, Python, C++, Java, JavaScript, and so on, whereas low level would be assembly language or machine code. And so typically what you do is you'd write as a programmer high level code. Sometimes there's an intermediate code that's generated by the system, by the computer, which then eventually gets converted into machine code, and that is run by or run on the computer. So how does this happen? There are typically two ways this is done, and nowadays sometimes you have a hybrid approach. But one is using what is called a compilation approach. So there's a compiler, and this is with languages like C and C++. And so you'd write your program like this. You write a script here. You create a file called sum.cpp. You'd also create a header file if required. In this case, not really. And you'd write a simple piece of code to add two numbers. Don't worry too much about what the structure or the syntax is, but this is C++ code. So you created a function, right, that takes in a and b, which are both integers, and returns the sum, which is also an integer, right? And now you've got a main function, which is what is executed. And so the main function is executed, and the add function is called, the result is stored in the variable called result, and then you view the result. What the compiler does is convert that through a series of steps, and we'll not worry about the detail, right? We're not going to go over how exactly and what are the intermediate steps, but it eventually gives you a binary file, right? And this is an hexadecimal representation, but as you can see, it's not very easy to read, right? And so you end up eventually with a binary file, which is your final kind of file that's run And so reading this is going to be complicated, and it's designed for the machine you have compiled it on, right? And then you would execute this binary file, and that code would be run on the computer, right? So this is how a compile process works, right? Where your code is taken, the compiler converts it in one shot. It converts the entire piece of code into, eventually through a series of steps, which we're not going to worry about, into a binary file, and then that file you have to run, right? Which means any errors are caught right here in the compilation process, and only if the entire code is bug free, then does it then get converted eventually into this binary file, and then you run it. On the other hand, the other approach is called an interpret. You involves an interpreter, right? And so an interpreter, for example, JavaScript and Python are examples of languages that use interpreters. You'd write a simple script, and in this case, Python, so it's a .py file. Same, you're adding two numbers, and we've seen this function before. You're saying a is 5, b is 3, and the sum is a plus b. Now, what Python does is it creates an intermediate file which uses what is called bytecode, which is lower level. So it's a series of instructions, as you can see. And this is an example. This is not exactly bytecode for this, but I've just created a representation. So that effectively almost is like a compilation because it's done to speed up execution. But then actually when it's run on the system, what is then done is the Python interpreter then takes the first line, converts it into machine code, runs it. Then takes the second line, converts it into machine code, and runs it. And so if you run Python code, what you'd see is, right, if the first line is correct, it would get executed. And then the second line is correct, it would get executed. And if the third line is wrong, it would stop execution there and say that there's an error, right? Because, you know, it's running it line by line. Whereas in C++ or C, if it's a compiled language, it would catch the errors in compilation, right? And it would not run until the whole code has been debugged. So let's look at a few differences between compiled and interpreted languages or approaches. So obviously compiled languages, C, C++, Rust, Go, Swift, and some places where interpretation is used, Python, JavaScript, PHP, Ruby. Although we have seen, say, something like Python already, where there is a bit of a compilation initially to get it to bytecode, but basically the execution is using an interpreter, right? And so, as we've seen in with a compiler, the code is compiled to machine code and then executed. Whereas here, it's interpreted and executed line by line. And so, in this case, it's compiled or pre-compiled and then it's executed. So it's much faster because it's executed properly in one shot. Everything else is done before that. Whereas here, you're going line by line, right? So obviously, and so as you can imagine here, the executable created is set up to run on that machine. And if it's a different machine, typically you have to go and recompile it on that machine. Whereas with something like, say, Python, it's quite portable. You can go take it on a different machine. And as long as the Python interpreter is installed there, you can just run the code, right? And so it's also easier to look at the code files with something like Python. Whereas here, if it's just a binary executable, you can't read it really. Okay. So you've got the basic idea of the difference. And so here we have a list of a few very widely used programming languages. And you see JavaScript is the most widely used as of 2024, obviously because websites are built in JavaScript. Same with HTML, CSS, but Python's not very far behind because Python's also used for web development, but then data science has come in and Python is king when it comes to data science, right? And then of course there are other languages there. You see C and C++, you have Java and so on. Okay, great. So clearly a lot of programming languages out there. Let's look at a simple case now. And again, the course is on Python, but we're going to add a couple of numbers just to see how it would look in different languages. The idea here is not to teach you how these languages are. The course is on Python, but just to give you a basic idea of what programs look like, right? So in C, you would have this header file, which is included, right? And so that would bring in some dependencies or functions that come in. So for example, if you are, trying to print something, you need to include a dependency, right? Where that is set up. Right? And this is not a class in C, so I'm not going to go into more detail. But you see a function here. It says it's returning an integer. It's being passed into integer. So you're specifying the data type. And a function is where you give in a value and it returns a value. So you're giving it one or multiple values. In this case, you're giving A and B, and you're returning the sum. And then the print here is printing that, right? And then typically, as you can see with C and C++, it has a main function, which is where the execution begins, right? And so the main function also, if you have started off with an int, meaning it says it returns an integer, you generally end with a return zero. And we have C++, different header file, and then there are what are called namespaces in C++. So that is used here. Let's not go into that. We're not covering C++ here, right? That's a very different class. Um, but then again, function, and you can see they're quite similar, C and C++. And so it's again returning a plus b, takes in two integers a and b. And then the main function where you're saving the output of that in result, and then you're visualizing it. The visualization is different. You're printing it to the screen or the console. Here it's using a printf, and a way to do it, here you use cout, right? Which is what is kind of read in with IOStream, right? Which is reading IO input out. And then of course you have JavaScript. And so this is kind of what runs on browsers. And so here now you have a function, and it's defined differently, as you can see, right? And you're not giving it a return type. You're not telling it what you're returning. You're just saying it's taking in A and B. It's called add. And you're saying it's a function by saying function, right? Whereas here, this structure itself indicates a function, but then it uses curly braces. You're saying return A plus B. You're not specifying the data type of A and B that is passed in. Depending on what you pass in, it assumes that. And ideally, it's an integer. Otherwise, this addition is going to goof up, right? And then you store that in result, and you say let result. And depending on what comes back, it's stored here. And you view it on the console. So console.log will print it out in the console. And then, of course, Python, which is what we're here for. And so Python structure is different. You use def, set up a function. Don't worry about it. We'll cover functions in quite a bit of detail. So add a plus a b, and as you can see here, again, we don't specify the type. And then it uses the colon, yeah? And you return a plus b. And you say result. And again, here you don't have to use any type, any let, any variable, nothing. It just knows that its result is a variable, and depending on what is returned, it's typed accordingly. And then you use the print statement. So you've seen how different languages doing the same thing. They're all high-level programming languages. These two are compiled. These are technically interpreted or use an interpreter. And how they've got different syntax, but you can already start seeing a pattern. Right? Okay, so great. You've kind of got a basic idea of what coding is. And so now that you've got the basic idea, you've seen what a programming language is. The next lecture, let's start diving into Python and write your first line of Python code. Okay? So stay tuned for the next one.